Hello everyone. Can everyone hear me? Actually, I'm having some problem with the video, uh, so that part is not visible, I think. Just 1 minute, if I can see if I can get the camera to work. Uh, okay. So unfortunately, my video camera is not working, webcam. So this is it. I hope you can see the presentation slides. Hello.
Yes, we can.
Okay, thank you very much. So this is the machine learning and deep learning fundamentals and applications. That course that you have on NPTEL. You must have all registered on there, and that is why you are here. Uh, so, so first of all, introductions. I am Anirban Rai, a PhD student in School of AI, IIT Delhi, and I am here because of the PMRF obligations that I have of teaching duty that I had to deliver. Mostly we will be focusing on doubt clearing only. Sometimes maybe little bit of theory here and there. Um so that is the overall idea. But your request and demands uh, will be well appreciated. What type of sessions do you want here? Um, okay. So already quite a few numbers here. 43. So, like, what type of backgrounds you are in? If somebody want to discuss, if want to say, like, why are you doing this course? I would love to know, as it is the first session. So, if anybody want to volunteer and um, describe why they want to do this course and what benefits are they expecting from this one, and what type of background are they having, and what challenges they might face. I would like to know that so that I can resolve those better. Hello, anybody?
Yeah, hi,
Hello,
Anirban.
hello, Amitabh.
Yeah, hi, good evening. So
Good
I'm
evening.
I'm joining from Bangalore. I work in Cisco systems and mostly in the embedded background. And I was keen to learn the machine learning and stuff, which is going around the industry. So I'm joining this course with zero expectation because
With I couldn't hear.
I'm joining this course
Hmm.
just to get whatever I could get. I do not have as such any specific target or something,
Acha.
but
Okay.
just
No
to be
problem.
aware of the terminology and how things are getting done. And maybe at the end of the course, I would also be able to know how to make an application on based on the machine learning.
Acha. Acha means like application point of view, it is important
Yeah,
for you. So
no,
that.
it's not important, but just one like somebody is making application, just wanted to understand the uh,
Okay. Okay.
concepts behind that because I'm from the mostly embedded background,
Acha.
electronics engineer.
Hmm.
So this area is new to me, and I thought this would be a good way to learn.
Okay. So in machine learning, a little bit of knowledge around probability is very important. Uh, okay, and what I have seen today, probability is significant,
Yes,
and
yes.
usually there is a lot of application of linear algebra as well, and a little bit of optimization. Optimization not very necessary. Usually, little bit that is required is usually covered. Okay, but probability and linear algebra are in like significant quantity, you can say. So some sort of knowledge on in these two areas is desirable, as you can understand as well from the first few exercises that you have done. Mm, okay, and the assignments are there fortunately in this course. The previous course that I did, there were no assignments, so students were mostly learning theoretical but were not able to apply. But in this course, it is there, so that's a good thing. And and so, anybody else like would like to say something?
Hello.
Hello, yes, Samraki.
Yes, I'm from West Bengal. Actually, I have done masters in mathematics, but after that, I get interest in this machine learning and deep learning. So I want to pursue my career in this field.
Very
Uh,
nice.
in last 2 or 3 months, I have seen some videos, but in Python, I am very new. I mean, I just know the basic things in Google Colab. That's
Acha,
it.
acha. So for Python, what I recommend to people is like let me present you the screen, full screen. So for Python, what I did when I learned was like I um, I went to Hacker Rank actually. Uh, Python hacking, no. So this is like a very well designed one. If I can show you. So So okay. Uh, so what's happening here? So what I was telling is like this course, as you can see, not course, actually just tutorial. Uh, so if you go to one problem, so there is a problem statement here, and they would like to write the code here, and you can choose the different versions of Python here. Python 3 is the recent one, okay, updated, and also the best thing was that uh, there's always a tutorial here, but maybe not on this one. So if I come to this one, mm, so this is what I used initially to learn Python. Keep solving problems here, but there used to be a tutorial, but it isn't now, I think. Or
Here, after writing the codes, I can submit it as well, right?
yes,
Nice.
mm, but there used to be a tutorial as well, so you could learn. Where is that gone? Uh, acha, maybe that is not the one. I think this is the one, or who knows. Let's see. Come on. This is the one, I think. Yes. Solve Python. So as you can see, there is the description of the problem, and there is a tutorial as well here, where they have written what to, means written what you need to know. Okay. So tutorial part is very from this tutorial you can learn first, and then see the problem and code accordingly. So suppose loop. Okay. So if I come here, so there is the tutorial as well. So I come to the tutorial first. So they have explained how to write a loop here. So you read this, okay, and then go to the problem. So there is the problem written as well, and then accordingly you can write the solution and then submit the code. Okay. So this is what I used previously to get started on Python. HackerRank is usually best for any language you want to get started on, coding language. Okay, so not the upper ones, actually this is the one, solve Python. Okay, so this is the one actually, and you can set different levels as well, at which levels you are in. mm. But not much is needed in machine learning, just I think up to list, and list is enough, I think. More than that is not required, but you could practice. Okay, so that's the coding part actually. Anything more?
No, that was actually the thing. And I am doing coding actually Google Colab.
Google Colab is nice. Means that from that you can. Acha, link I should share. Okay, so okay, and Google Colab is nice because you get the computer resources and GPUs there. Um, that is not present in means like other places you will only get the CPU. So uh, so that is why Google Colab is important, and in this assignments it will be, I think, quite important, because this is not just a machine learning course, this is also in deep learning. So where was the course? Here it is. uh, Up to this day it is week 2 machine learning going on, but later on we'll touch on deep learning as well, and the assignments there would require GPUs, I think. So the Google Colab is the one that is recommended. Also, there is Kaggle actually, Kaggle in which you can get GPUs, and the restrictions are less as well there compared to Google Colab, so can be a better alternative. Okay. So anything more? Anyone wants to discuss?
Hi,
Hello.
I'm Dhruv, currently pursuing my bachelor's from IISER Bhopal.
Okay, very
So,
nice.
in engineering science, and like I am, the main reason I choose this course is basically, I think deep learning and machine learning will be the most fundamental thing in future for a software developer or a software engineer. So I think the early you learn, the better you will be in
Oh, very
future.
nice, very nice. And
Yeah.
so like so you're okay with probability and linear algebra maybe?
Yeah, yeah, I have completed linear algebra course in my first year already.
Okay,
So
very
yeah,
nice.
I have- yeah,
Okay. And so very nice to meet you, Dhruv. Uh, so hope you can become a very good software engineer future. And
yeah. Thank.
yes. So anybody else?
Hey Anirban, this is Raju here.
Very nice to meet you, Raju. Good evening.
Yeah. Good evening. Same here. See the present world. There is hype on AI, machine learning, data science, and all. See, basically, I am from a program management uh, uh, professional.
Okay.
So for me, the whole purpose is, when I work with a team. So I am not interested in coding, and nor I will be doing the coding in future too. But the whole purpose of learning this course is, whenever the SMEs talk between themselves or with the client,
Okay.
I should know the what they are trying to say. Instead of treating everything as Greek, I would like to understand what communication is happening, what is the ask, and what is the solution my SMEs are giving. So that's the whole purpose for my selecting this course.
Okay.
So how does it help me? I mean, I did my engineering long back, so uh, regression or linear algebras and all those are already out of my head.
Okay.
So how do I start
The
this?
basics you have to brush up. As you can see, this is a course I'll link. I think this is the one. Um, as much a, as much as you can do is good. Okay.
Hmm.
Fundamentals are needed. Probability and uh, linear algebra. Okay, this is the one I think. And video lectures are on YouTube and here as well. Prefer from here. As much as you can do, that is
Can
better.
we share the link?
Yes, I'm going to share. Um, so, Pranali, the yesterday's session was taken by another TA, not by me. Um, okay. So what was I saying? So as much as you can do, that is good for you. Everything is important here. Hello, anybody saying something? Okay, as much as you can do.
Hi, sir. Am I audible?
Yes, yes, Deepak.
Yeah, actually, I just want to know like whether in our subsequent assignments we'll be doing the coding part also.
Yes, assignments are for coding only. Otherwise, you can just learn from the videos. But implementation is also important in a applied subject, and you implement machine learning theory through codes only. So that is and coding also helps you understand better, so that part is also there. For suppose
Yeah,
people.
but that coding part, whether will be taught here, sir, like in the course, because or only the theoretical part.
Mostly I think was will be theoretical only. Coding, you have to do it yourself, I think. And suppose
Okay,
for
but the coding part will be coming in the assignment also.
in the assignments only. No, in I think they're separate. I think you don't have any assignments for
There,
now. Okay. Uh,
no, in the subsequent assignments, whether it will be coming with the coding part also.
yes, there will be some. I think in the previous year courses, I think I saw. I think here somewhere. Uh,
Then those coding parts, like how to, sir, like,
was like depends on a priority as well. Suppose for persons like Raju, like he said he's in a managerial position, he doesn't need to code, so he can skip. Okay, but like mine's like depends on your goal. Suppose someone wants to be a software engineer, um, needs to code, right? So they should do it. And so depends on the goal. And you say how to get started. Well, I explained it right before. uh, get to hacker rank here. Don't need to learn much here. I think up to this list, I think it's enough. List and tuple is okay. Others are also important, but machine learning mostly not needed. So I
but
think
towards the machine learning also, those packages, sir, like which package to be used, which are
which
not,
for
like
that,
how
like
to.
yes, for packages and libraries, what you should do is like search on the internet for similar implementation, and see what type of packages they have used, how they have used the packages. Okay. Means like from seeing codes you can learn how to code as well. Okay, if you don't know, but the basics are here. Okay. I think to somewhat this level is enough. I think strings, I think something around strings is enough. I think nothing more is required here. Okay. So this is it. And uh, so okay. Uh, anything more, like anybody wants to introduce himself or herself?
Sir, I myself Sandhya Sharma. I
Very
want to
nice to
know.
meet you. Very nice to meet you.
Same here. Sir, I want to know the linear algebra specific topic of linear algebra.
The thing is like linear algebra is very important for machine learning. And
Sir, because I did my 12th in 1995,
okay,
so
okay. That's a
that's why I
long
have
time back.
long time back,
Yes.
so that I have problem in mathematics.
Acha,
That's why
acha.
I'm asking.
If you have problems in mathematics, uh,
So you can specify the topics. No? I will revise.
um, overall
Linear
means
linear
you
algebra is
remember
big.
remember matrices and vectors, these things little bit, huh?
Okay, okay,
And then if you can means like if you can understand the first lectures, then you can proceed with that. Okay. However longer you can do, it's like overall everything is important here. Okay. And
okay,
if you can understand the first lecture, you can easily progress through the course. But if you cannot even understand the first lecture, well, that is a problem. So for that, like, better is to just understand how much, however much you can.
okay, sir.
mm,
Thank you.
okay. uh, so like okay. So how much statistics is needed? Statistics, mostly not much actually. In Means like even the statistics part is means the even the statistics that we will use will be harder because of if you don't have the knowledge of linear algebra. In a higher dimensional statistics, the hard part is actually linear algebra, not the statistics itself. Uh, but but in but the basics, I think, basics will be taught as well, I think, here. What
Oh,
is mean and variance, those things. I'll be doing that, okay,
okay.
as well. So that is it. And linear algebra, other than linear algebra, a little bit of probabilities are needed. Um,
Okay.
so probability, proba- probability not much, but to understand it very well actually. So probability based course is, if I remember, it's a little bit of easier one. And I've got a very hard one. Uh, I think this one should be enough. I think. Uh, okay.
Okay, sir. Please share the link.
Okay. Let's see how much is there. Uh, Introduction to probability and distributions. Okay. In this, you don't need more than week two. Okay, week one and week two are enough for now. Okay.
Okay. And you said in linear algebra, matrix and vector is enough.
Linear algebra, yes.
Okay.
Linear algebra and probability. Linear algebra is fully important. As much as you can do is good for you. Uh,
And linear algebra, matrix and vector, and some other thing.
Means like matrices, vectors come inside linear algebra only.
Okay.
Uh, so machine learning and deep learning is also helpful for ENT's BTech. What is ENT? Um, ENT is what, Pranali?
Hello, sir.
Yes. Actually, yes. Everybody can learn if you have interest to learn. Then what's the issue? And yes, Jyoti, what you're saying?
Sir, I'm saying that how to practically do for computer vision. Where I
Computer computer vision, like this is if you see the syllabus, I think there should be significant component of computer vision here.
this
Um,
is taught for me.
just wait a minute. So computer vision, as you're saying, is
My first lecture I learned this in this course. But how to practically work?
uh, so computer vision, we used CNN, as you see. In week 11 we are getting to CNN, as you can see. And this is not a dedicated course for computer vision, but you can find the content in week 11. Okay. um,
Practically, sir.
um, and just check out the week 11, and you can do it. I think I don't want to go into depth of that uh, for now.
For
So
knowledge purpose, where I use this course.
yes, this is not the best course for computer vision. You maybe if you want to dive into computer vision, you can get a dedicated course in NPTEL. This is not the best one, but here,
You may share any link
uh,
for best
uh, uh,
which I practical.
um, I will not be doing that because this is not the relevant area for us. Okay. So you should find yourself, and in this course, week 11 is the relevant computer vision uh, week, you can say. So in that you can get the information that is needed. So enough with the edu. We will get started now. Hope you learn. Hope you enjoy. So this is it. Can you please everyone mute themselves, or I can see if I can do it. Host control. Okay, so let's everyone get started. Uh, so so first of all, like we'll review the basics here, uh, and I'll be explaining the things as well. Hybrid electrical vehicle. The recordings will be shared. I don't know what you're talking about. Hybrid electric vehicle uh, can be applied many areas, but I'm not sure actually. And let's get started now. So we'll be reviewing the basics here. So first, the matrix becomes. So the theory is something like this. The singularity of the matrix is defined as uh, the means a matrix is a square matrix whose inverse is not possible. Okay, cannot be calculated. So if it is non-singular, then the inverse is possible. Okay, so this is the inverse notation of a matrix. So we define it as the adjoint of the matrix divided by the determinant of the matrix. Okay, so as you can see, this is the inverse. Okay, if it is singular, then this is possible. And the definition of non-singularity practically is that we make the determinant equal to 0, or better to say, if the determinant of the matrix is equal to 0, what happens is that the inverse of the matrix is not possible. And why is that so? Because you can see that we cannot divide it by, we can to calculate the inverse, we need to divide it by uh, mod of a, that is the determinant of a. But and if it is a non-singular, the division, if it is singular, then division would not be possible. So for to calculate this one, you need to put the determinant equal to 0. Okay, that is the definition of singularity here. So how will you do this? So little bit of refreshers as well. Let's see what is the answer. Samragi has already told it is 4. So 8x0. I need to buy a writing pad as well. May not be very easy to read here. Okay, so the how you open a how we calculate determinant is like so first you write with the, if you open with the first row, that is what usually people do. They cut out the elements in the first in with respect to that element and multiplied this. Okay, 0 0 is 0 and 6 2 is 12 minus 12. Okay, then suppose this is position 1, first column, first row. Okay, the sum of this is 2. Okay, so that is even. If it is even, then plus comes here, and this, as you can see, first row and second column, so it is odd, the sum is odd. Okay, 1 plus 2 is 3, so the minus comes here. Okay, so this is x. Now what comes is that you remove these rows. Okay, what happens is 400 and 12 24. Okay, next with 0 I will start with 0, so 0 multiplied something is already 0. Okay, so this becomes 0. Okay, so minus 72 okay, and equal to, so this is minus 24. Okay, so this x becomes, did I do it right? 12 6 and 2. Answer I'm getting is 3 actually, Samragi. Did I do any wrong or did you do any wrong? uh, but I'm getting 3 only. 96. Acha, 12 8 I have done wrong, I think. Acha, it yes, got it wrong actually. uh, okay, so it will be, yeah, it will be 4 only. Sorry, very sorry. Now the eraser is where, draw. Acha, this is the eraser. So 4 is the correct answer. uh, this part I have done wrong. 96 is the one. Okay, so solving the equation you get the answer 4. Okay, next, a real square matrix is there. Okay, real means the elements of the matrix are real valued. And hello sir, for machine learning TensorFlow or PyTorch, which is more useful? Or, well, what happens is, for machine learning, for and specifically deep learning, PyTorch is usually easier to use uh, for making custom algorithms. And PyTorch is usually preferable. Okay, so use that, because for custom algorithm making, PyTorch is easier. And if you don't want to make custom algorithms, then both are same, I think. uh, Same preference. Okay, so next is that real, all elements are real. Okay, and it is square matrix, so you can understand that both the dimensions are same. So definition of symmetric is that, suppose you have a matrix X here. Okay, so if X transpose, okay, so you take transpose of that, if that is equals to X, then it is symmetric. Okay, so that is what we're going to do. So this is the matrix we have. Okay, sir, I have to leave now. Yes, you can leave now. uh, yes, recordings will get, everyone will get recordings will be posted on the uh, NPTEL page. Okay, uh, so you will have the recordings there. mm, let's rest we need to progress now. I will answer the doubts later. So what will we do is, like, we'll test this thing. Okay, so we need to take the transpose of this. Okay, so this will be equals to, as you can see, so transpose, we have to take the last one first. So that is the way you take transpose. So A transpose, and then this one. Okay, so the order change reverses when you take transpose. So transpose is same. Transpose of the matrix is, transpose of transpose twice gives you the same matrix. Okay, and this is A transpose. So you can see we started with A transpose, we after transpose we get the same. So this is symmetric. Okay, we proved it is symmetric. Next, uh, so this is one question where you need little bit of extra linear algebra, you can say. uh, so let's see something here. Okay, so so the rank of a the rank of a matrix is defined as the number of independent column vector or column spaces or row spaces as they call. So to give you an example, I've made an example as well. Just wait a minute. Okay, so 1 2 3 and 2 3 4 4 6 8. So as you can see, this is this is one matrix example I've took. So we need to find how many you can clearly see that these two are dependent. Okay, so actually there are two actually uh, independent row spaces here. Okay, so the rank is 2 here, and the matrix is 3 cross 3. Okay, so what we do here is that to find the rank uh, some so the method is like this. I don't remember the name of the method. I think it is called Gauss-Jordan method or something like that. So suppose this is the x. Okay, so the method is like this. Okay, so this is oh my god. So this is our x variable matrix of 3 dimension, and the results are okay. Okay, so this is the one, and so for okay, so the rank part you know. So finding the rank is another exercise which I do not want to go into depth. Okay, maybe I want to refer a link here. This is the one, I think. Not fully sure though. Yes, I think this is the one. So Gauss-Jordan method is the one to find the rank, but here we are already given the rank is 2. Okay, so if for this example you can find the rank. Maybe you can take it as a homework, and what you can do is like so the number of solutions of a of these equations are called actually as nullity. Okay, so they are defined as nullity. So nullity of x, and that is defined as the dimension of the matrix, that is n squared matrix. Okay, n minus rank of the matrix, uh, say A. Okay, so the dimension minus rank. So the number of independent solutions are n is 3 and rank is 2, so the answer is 1. Okay, any doubts you can write into the chats. Okay, I have muted everyone to reduce noise. Oh, sorry. Okay. Okay, and some other things are also there, less concise one. So first is the Gauss-Jordan elimination you will do. I thought I will not show it, but let's see. So you make twice of the first row and subtract it from the second row. So this becomes 0, this becomes -1, this becomes -2. Okay, next 4 times of the first row and subtract it from the last row, so this becomes 0, and this becomes -2, and this becomes -4. Similarly, what you do is make twice of the second row and subtract it from the last one, so this becomes 0 and this becomes 0 as well. So a number of non-zero rows represents the rank. Okay, that is there. Okay, next what you can do is that uh, uh, next what you can do is next what you do it is, so these are xyz variables are there. So first you took the z value, okay, and you can see that -x minus 2z equals to 0. So as you can see, x becomes -2z. Okay, z is already z, and you put the values here. Yes, so what does that become? X plus 2y plus 3z equals to 0. Y becomes is equals to 3z minus x by 2. Okay, now x is equals to -2z, so it is like 5 by 2z. Okay, so as you can see, this is our solution set. So if we consider the third variable to be z, say the y is 5 by 2z and the first variable is -2z. So what we can understand is that given a solution, one solution independent solution, the other two are dependent on that, so there is one independent solution. Okay, so so that is one. Less elegant method. Okay, so this question is simple enough actually. So first what you need to do is solve the or you can do it like do it on that way as well, like that way is not possible, I think. So what you do is need to do is solve this two. Okay, uh, find the value of x and y. Okay, so can anybody has done it? What is the value of x and y? Write it down in the chats. Nobody? Okay, uh, so simple two-dimensional linear equation, two variable, and the answer I got was let's see, uh, okay, the answer I got here uh, well, I think I haven't written it properly. Okay, I think someone has answered. 9 by 4 and 1 by 4, very nice, that is what I got. So x is equals to 9 by 4 and y is equals to 1 by 4, and if you put the values in this last equation, you see it satisfies this solution. So means 9 by 4 and 1 by 4 is the one solution, unique solution we have. Okay, so and another thing we need to understand is like this equation is a trivial one. Okay, what does it mean is that uh, you can derive this equation, last equation, using some combination, linear combination of the first two. Okay, so what does it happen, what does it mean is that you don't have any new information, but you're manipulating the first information from the first two equation. Okay, so uh, so what does it do? uh, Means I can show you as well. I think some combination I can see. uh, so you make twice the second equation and add it to the first equation, so you get this is x. Okay, and this is 3y. Okay, so this becomes 3. Okay, so twice the second equation, sum it up to the first equation, you get the last equation. Okay, so that is one thing. And another thing is like, suppose this was a new information. Okay, it cannot be made with linear combination of the first two equation, then we will have zero solution. Okay, why because from the first two we will get a solution, but it will not satisfy the last solution. Okay, so in that case we'll get zero solution. I think everybody got it. Understood? Okay, so for that I need to unmute. Thank. Okay, you can speak up now, Amitabh.
No. I think it's fine.
Fine, right?
So, yeah, it's fine. Understood. I just wanted to say thumbs up by mistake.
Okay, uh, so this is a question of combinatorial style probability question, uh, and very simple still. Okay, so at least one head or one tail, okay, needs to turn up. So what we'll do is 1 minus, so you can see when no tail comes up. Okay, so that is all heads. Okay, and another is no head comes up. So these two are the cases that go against us. Okay, so this is 2, and the total number of cases is, for every position you have two choices. Okay, so it is 2 to the power 4. Total number of possibilities you have is 2 to the power 4. This is 1 by 8. 1 minus is 7 by 8. Okay, so very simple question actually. Clear everybody? Okay, some doubt I think. Yes sir. Okay, so next question is based on the Bayes theorem. uh, how I love to solve this type of questions, the simple approach actually. So suppose the so as you can see, the question is, uh, so the probability that it was drawn from bag 1. Okay, so we're drawing balls from bags. Okay, so I will actually imitate the process here. Okay, so this is me, a person here. So I'm drawing balls here. uh, so what I do is, there I have two possibilities. I take it from bag 1. Okay, and another is I take it from bag 2. Okay, so I have two possibilities here. I take the ball from bag 1, or I take the ball from bag 2. okay, and they are equally likely, okay, so with half a probability. Okay, everyone okay with this? Next, what I do is I draw a ball. Okay, so ball can be black or white. In this case also, ball can be black or white. So the probability the ball is black is 6 by 10. Simple enough. Here it is 4 by 10. Okay, here it is black, it is 3 by 7, and white is 4 by 7. Okay, so this is the diagram I've got, means what I could have done while drawing a ball from any of the bag. Okay, find the probability that it was drawn from bag 1. Okay, so our desirable situations probability has to be on the numerator. Okay, so it was drawn from, okay, acha, so the conditional probability part is also there. It was found to be black. Okay, and so as you can see, so what we need is, first in the numerator, what we need is probability that it was black and bag 1 both. Okay, it is our desirable case. As you can see, it was drawn from bag 1. Okay, but it was already given to be black. Okay, and next we have the probability that it was black. Okay, okay, so to write it down, what it occurs is, so probability that it is, so it becomes probability it is bag 1. Okay, you can write it like this: probability that it is black given bag 1. Okay, divided by summation of probability of bi, probability of, it can be black or white. Okay, so something here, divided by bi. Okay, actually you don't need to do these things. The easier path is like, means I have means like written the base root for this one, but the easier way done is, just check which condition is favorable for us. Okay, so as you can see, uh, from the numerator, what we get is probability that it was drawn from bag 1. So bag 1 has to be there as well as black. Okay, so it is half into 6 by 10. Okay, okay, that part is done. Okay, and in bottom it has to be black, the probability of occurrence of that we have occurrence of black balls. Okay, so it can come from bag 1 as well as bag 2. So bag 1 case will be the same, half plus 6 by 10. Next, what it will be is 3 by 7 into half. So you can remove every half here. Okay, so this will be 6 by 10. 6 by 10, sorry for the handwriting. And this is 70, 42, 42, 30, 72. It is 72, right? 42 and 30, 72, yes. And this becomes 70, so that goes up. Okay, this 0 0 cut, This becomes 42 by 72. So divisible by 6. Okay. uh, 7. Okay, and this is 12. The answer is 7 by 12. Okay, got it. Any doubt? Can you please say the statement of the formula again? So this is actually Bayes theorem. Okay, what I have written here, if you remember, this is the Bayes theorem, and this tree diagram actually easily represents the Bayes theorem, and you can easily use the Bayes theorem. Is that you don't even need to remember Bayes theorem, just put the values likewise as you need black here. So b1 into b, okay, that comes on the top. Next what you have is b2 into b, means in the bottom b2 into b, and uh, and b into b1. Okay, both the situations here in the bottom and top, only one situation. Okay, can be little hard to understand initially. Maybe we should try it back later again. So next is like they're looking for standard deviation, so a little bit of work actually. So variance is there. Okay, variance of a random variable is defined as expectation. You know, expectation of the random variable minus mean of, sorry, okay. So this is the one. So this is the definition of variance, and what I need to do here is that, so this is variance, and so first of all I think need to explain expectation. What is expectation? So expectation is actually practically mean only. Okay, mean, that is denoted by mu. Okay, that is expectation, and the mathematical definition is expectation of a random variable expectation of a random variable for continuous distributions, continuous probability distribution, is defined as the integral. Okay, integral over the domain of the probability distribution, domain of the random variable. Suppose it is uh, suppose curly x. Okay, something like that. Okay, and it is fx. Fx is the PDF. Okay, into x, that is the random variable, into dx. This is the integration. Okay, this is expectation and this is variance for you. Next what we do is, there is a simplified form of variance. So okay, let me do that. So expectation, so this is variance. So I open the square inside, 2 into x into ex is expectation plus expectation x square. Okay, so I have just opened the square that was inside the expectation. So this becomes, expectation is like a linear function, so it goes over every element inside. Okay, so expectation of x square and expectation is the same. Okay, it is a constant, it cannot be taken expectation over. Okay, so expectation is only apply over this x. Okay, so this becomes minus 2 ex square. Okay, again expectation over expectation is same, just expectation. Okay, so this becomes just 1. So let me write it down. So this becomes just 1 time. Okay, okay, so this is the formula for variance. Okay, simplified. Okay, this is 1 only. Okay, let me write it down carefully. This is the formula of the for the variance, and the question we have here is this is the one, I think. So okay, uh, 1 minute. Maybe we should take a 5-minute break. Okay, then I will come back. Okay, so we will start at 7 means 5:12. Okay, so okay.
Hello, sir.
Good evening, everyone. I am back, and so let's continue our discussion. Okay, as we have derived the formula for variance here, and this is the question here. So, so another important factor here is the what is the uniform distribution. Okay, so uniform distributions PDF small fx is defined as 1 upon b minus a, sorry, b minus a, this is b, and when x is between close brackets a and b, otherwise it is 0. Okay, so this is the PDF, but given my handwriting, let me explain it from Wikipedia. So we go to Wikipedia. So very well, you can see here. So this is the PDF. Okay, so what does that mean is, so this is the probability distribution. So it remains at 1 upon b minus a for for uh, for x from a to b, and okay. So I hope you understand PDF actually, but if you don't, let me explain you a little bit. So the PDF is actually not the probability, but probability density. It is similar to, like, if you consider probability as mass, the probability density is this density. Okay, and okay, okay. So probability density is just Acha, and one more thing is, like, I'll be sharing the videos on YouTube. Okay, the link will be shared in the course, but you can anyway follow me here. Okay, and subscribe and ring the bell notification so that you can get updates as and when the video is uploaded. Okay, so this is the link. This is where I will upload the session videos. So here it is. You can subscribe. Okay, and get notifications for that. Let me see if the subscriber count goes up right now, uh, or maybe not. Let's see. Oh, it does go up. Thank you very much. And so we continue here. So as my handwriting wasn't too well. Okay, so here we go. So this is just the density actually, and you can see we calculate the area under the curve, which is represented as this, and you can see the CDF, that is the area or the probability, as you can say. So CDF represents the probability. Okay, so the maximum range is from 0 to 1. Okay, so this is as you can see. Okay, and okay, and so you can understand this one, probability distributions, density, probability density function, and cumulative distribution function. So that is there. So just you have to use the formulas here, expectations formula. Okay, so that becomes, so expectation of x square is equals to integral 0 to 1, as they have written. Okay, and x square into 1 by 1 minus 0, that is 1, and dx. So you have to calculate this integration. that is equals to 1 by 3. Okay, next e x you have to calculate, that will be x times this. Okay, x square by 2, so 1 by 2. Okay, so the answer will be 1 by 3 minus 1 by 2 squared is 1 by 4, 1 by 12. Okay, so we got the variance. Standard deviation is square root of that. This is the answer. Do you have any doubt? Any doubts? Thank you very much. The count is going up. So any doubts? Got this question? Is an important question, actually fundamentally important question. So okay, let me wait a little bit. Okay, no doubt, I think. Okay, so let's progress further. So this well, these two questions means the answer is wrong. Actually, options are all wrong. Okay, so the answer is different. Okay, it's like anybody's option matched here. Actually, it can happen that I have made a mistake. Okay, yes, I did not get the options. Means the answer that I got did not match the options. Okay, it can happen that I have done wrong. Okay, anybody's options matched here in these two questions? Let me show you again. Anybody's options matched here? Can anybody answer if they got anyone one option as the correct one? Acha, these questions were taught, as you say, and yes, that may have happened, but like I am not connected with the other TA. Options were itself wrong. Okay, okay, that's very nice. Okay, so that is what I got, and so this question number 10 must be very easy. Okay, I think I'm not going to explain that, and Poisson's distribution I have to show you. Okay, uh, so Poisson's distribution. Okay, so as you can see, the here it is probability mass function. Okay, so that represents the probability itself. Okay, and for number of occurrence that you're looking for. Okay, so there is the formula. Lambda is the mean here. Okay, this is the PMF here, and for that what you have to do is, so as they have given probability that x is greater than 2, so these are uncountable, so what we do instead is probability x is 0. Okay, 1 is 0 case. Okay, 1 is 1 case, 1 is 2 case. Okay, so what you have to do is put the values here. 0, if you put, what you'll get is e to the power I think e to the power minus lambda. Lambda is 2. Okay, so e to the power minus 2 you'll get here. For 1, what you'll get is 1, what you'll get is 2 e to the power minus 2. For 2 also 2 e to the power minus 2. Okay, adding those all together you'll get 1 minus 5 e to the power minus 2. Okay, simple enough actually. Another type of distributions like uniform Poisson distribution. Acha, Sanvi says that she has got the answers. So you get answer sheets or something? Like I don't have the answer sheet actually. Acha, if you submit, I think you get the answer. Okay. 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 So got it. I think understood. Question number 9. Similar to uniform distribution question. Poisson distribution and the type of distribution this is. Okay. Any doubts? Question number 9. No doubts, right? So let's progress on. In the binary classification problem, what is the confusion matrix? Explained in the lectures, but let me write it down still. So confusion matrix is the predicted by the algorithm we have, model we have. So this is, and this is actual. Okay, so this how many such samples or probability you have here. Okay, so this is true, what to call this, true,
True positive.
yes, yes, true positive, oh, sorry, so this is true positive, and another is,
False negative.
let me see, I want to do it accordingly, according to lectures, not create confusion. So this is, where did I go? So this is false negative, and another is false positive, I think, false positive, and true negative. Okay, terms are self-explanatory. Okay, actually it is useful in next questions as well, so that is why I wrote it down. This screenshots I have not taken other after that, so let me go to the questions quickly. So I think question number 2 is very easy, just given in the lectures, nothing extraordinary here. Question number 3 also, just you have to put the values. Okay, 3 4, any doubt? Question number 3 4, any doubt? Are everybody able to do it? It's not very hard, just arithmetic. Hello, anybody can say if has in doubt, could not do it, I just want to see how it is done, has not done it. Any doubt? Sandhya, any?
Can just show the, for example, for question number 3, can just show me the calculation how you're
Okay,
obtaining the result.
okay, okay, let's see.
For true positive is 90, and for incorrectly, the terms, no, we just want to space. No? For question number 3, can just teach us.
Okay, let's see. So this is the questions we have, and so this is our so the same convention I'm using, so I'm not going to label anything here. Same convention is going to be always used. This is the left, these rows are actuals, columns are predicted. Okay, 1 0 1 0. Okay, so what they have written is like correctly predicts 19 as positive, so there is true positive, right? This is going to be 90. Okay, and incorrectly predicts this as positive. Okay, so positive, and so that is a false positive, right? This will be 15 here. Okay, next I think this was 90, and this is 10. Alright, Sandhya, same.
Okay, sir.
And accuracy of the classifier, just want to
Yeah,
fit
that based on the formula, you can calculate.
fit the
Okay, fine.
formula, yes. And
Yes,
for
I can do that, sir.
F1 4, you can find the precision
Based
interval
on the formula, yes.
and
Yes.
harmonic, so just like that. Okay, let's move on. uh, this questions are good, I think. but more important this question than these questions are the theory here. Bias variance is very important, okay, and you need to understand the theory, okay. It is actually one of the most important concepts of uh, frequentist machine learning, okay. uh, okay so the overall idea, uh, maybe I can explain little bit, but maybe can be hard as well. Let's see. Means like lectures are there. I must you must have seen. Okay, but if you go into greater depth in this one, then can be better if you can. Okay. So what we have is, so let's see the subscriber count again. Not crossing 50 easily. So what we're looking at is Bishop. Okay, so this is the one, right? And okay, and we're the right page only. So okay, so Bishop is a very famous researcher, works in Microsoft Research, okay, and he has shown how to do the bias variance, first breaking that into bias and variance, and then analyzing the trade-off, okay, everything. As you can see, little complicated, but can be done, okay. Can be very good if you can read this one, okay, understand, okay, a little bit I can explain, okay. uh, mm, some very rigorous actually notation mathematics here, not like I have explained, okay. So so first they have defined the loss, okay, loss function, okay. Little bit of explanation, okay. I know you have done this question, I think, but more important is to get to the depth of the problem here, get to the depth of the theory here, okay. So okay, little bit of explanation, I hope. So maybe I should make a PDF of it, little bit of, okay, then you can carry over yourself. Can be hard, okay. uh, where did it go? So bias variance decomposition, as you can see. So first of all, he has defined a function hx here, which is defined as uh, like the conditional expectation, okay. So first you need to know the conditional probability, okay, of t given x, okay. So what is t here? T is the target, okay, means like the y truth values, okay. Like in these questions, as you can see, uh, the truth value is this y, okay. So this is the target t, okay. The t given y, t given x, x is the our independent variable, okay, okay, x, or let me see if I'm not wrong, notation is correct or not. mm, to see, still wait a little bit, have patience. They have defined it somewhere, I think. is here somewhere. Okay, so yeah, T is the prediction, I think. Yes. Okay, I'm sorry. So I think I told that one. No, I thought it's target. Okay. So I'm sorry. So T is actually the prediction, Y prediction, as in given in the question. Okay. So let's start again. Okay. So T is Y prediction here actually. Okay. And so we're looking at the probability of Y prediction given X. Okay. And this expectation, as you can see, conditional expectation, they say, they denoted it as H. Okay. So what does it give us actually? It gives us the mean of predictions that we are trying to make, means that is the you can say good representation of the, means like this is, or you can say it practically like that is the uh, this is our prediction. Okay, Y pred. Okay, so what we have done is like very rigorous mathematical way actually. I hope you try to understand it better. Okay, later a little bit of introduction I'm going to give you. Okay, this is a loss function they have defined. Okay, squared error loss function. So Y truth values minus Y prediction. Okay, this is practically Y prediction. Okay, so but as you can see, the probability that is needed is quite rigorous here. Okay, and so this is the mean of the prediction we're making, and this is the true prediction that we got. Okay, there's difference between that as well. Okay, so that error, so that loss is also added. Okay, first is the mean of the prediction. Okay, this is the main loss hour, and this is the loss between mean of the prediction and true prediction. Okay, so true prediction is T here. Okay, so next if we go forward, so they have broken down the functions inside. Okay, and they have analyzed, okay, to get to this. Okay, so this is the bias square here. Okay, so that is the expectation of, okay, what is this, the expectation of, as you can understand, this is the mean of the prediction. Okay, and this is the expectation over the data distribution. This is called the data distribution. Okay, and what does that mean is the mean of the truth values we have. Okay, so to give you an example, here the mean of the truth value will be mean of these. Okay, and this is the mean, and this is the predictions. Okay, so as you can see, very mathematically concise. Okay, uh, importance you can understand if you go deep into probability only, because as you can see, this is expectation over data distribution. Okay, and what we have here is the samples, some samples of the distribution. Okay, but as we don't have the full data distribution, you cannot calculate this. Okay, so in this problem we are also only going to take the mean of the samples. Okay, that is what we can do, no other choice left actually. Okay, and another is that, as you can see, expectation okay, so this is expectation over Y prediction. Okay, so give more time to understand that one. I think it will be very valuable for you. And further, what we're going to do is that bias you can do it. Okay, I think the formula is difference of the expectations. Okay, but I think the sign is also important here. So sign is what I'm going to tell you. Just wait a minute. I think the formula sheet is also there in the notes. uh, Wait a minute, I think. Okay, so expectation of prediction minus okay, I think expectation of prediction minus real. Okay, so mean of these, okay, minus, oh sorry, mean of these, okay, minus mean of the real ones. Okay, so that is the sorry, okay, uh, so what will answer will be mean of the predicted y pred, okay, minus y. This is our answer of the first question. Okay, answer I got was -1. Is the answer correct? Is the answer correct? Got the same? I got -1. And in the next case what we are going to do, use this one. Okay, uh, okay, use this formula. Okay, and I have shown you that you can break down it to expectation of y square minus expectation of y whole square. Okay, so you can do that one, and y here is the I mean to say the y predicted. Okay, so use this one, expectation of yp square minus expectation of yp whole square. Okay, for derivations you can refer to Bishop, you will understand it better. Okay, and let's progress further. Okay, what was trying to do, okay, next question of regressions actually. So question number 6, any doubt? Question number 6, answer I got is C. C is 2.2. I got 2.2 is the answer. Did you got the same as well? 2.2 is 2.2 the answer? 6 C. Is 2.2 the answer? So I haven't taken the video. I'm taking the video. Okay, so nobody's answering, I think. So I hope you have done it right. Okay, I got it 6C 2.2. Okay, next few questions based on regressions. Okay, not very difficult actually. So the question is like this, 7 and 8. So what I'm going to do here is that, let's take this screenshot. Okay, next we go on to solve these questions. Okay, so what we do is here is that so they have written as linear regression model. Okay, so for that, what we for linear regression, So we're fitting a curve actually, okay, and it is of the form y is equals to a plus b x. So I'm trying to fit a straight line through the data, the best fit curve having the lowest mean squared error. Okay, so for that, what we need to do to calculate the parameters is, I think there is a derivation as well. Do you know the derivation of the question number 7? How we get the formula actually?
No, sir.
You don't know, right? In the lectures it was not covered.
Sir, I joined today. Sorry to say, I joined today, so I have to go through the lectures
Acha.
and then only.
Okay. Anybody who has gone through the lectures, do they know the derivation? And I'm not going to show the derivation, but good if you know. Okay.
So we can refer books, then I can get the derivation.
From books, Bishop is there, but Bishop is everything like tough type.
Okay, from there I'll go.
Bishop is a tough type book actually. So the idea is not too much extraordinary. I'm not going to show the derivation. So what we do is summation of yi, okay, whatever value y values you have, sum them up, okay, is equals to a plus b summation of x. Okay, you do that. Next what you do is summation of yx is equals to okay, you do this, okay, these two.
So the second one is summation of yx
Yx, yes. So
equals to a plus b summation of x square.
yes, so you solve these two equations. You have two unknowns and two equations, so you should be able to solve a and b. A and b are the parameters of the linear regression models, and that is the answer to the question.
I'll try. Thank you.
Okay, everybody okay? I have not done this question because it is quite hard work actually, a lot of calculation. Okay, there is a matrix formulation as well, okay, called normal equation. You can use that as well if you'd like to. Matrix one I can show from Bishop right now only. I hope you can understand that. So this is the matrix one. This weight will contain a and b, okay. uh, so this is the matrix formulation. I don't think I'm going to explain this one, okay. It is better, it's good to know, okay.
Okay.
So it's good to know. If you can understand this, you can refer this, okay.
Page number sequential learning.
Okay, you can mute your mic actually. Okay, very nice. So next question is MSE. You have to calculate. So MSE is y truth, yt I represent, and y predicted, that is this one, okay. So truth minus predicted square for every sample, then you have to sum it over I, then take mean over how many samples you have. Let's see, 7 samples, okay. So mean over 7 and you get the answer. Got it? Shanti, you can talk.
Yes, sir, I can try. I'll try take 7 samples, then take the summation and mean करके कुछ निकालना है, sir. I have noted down.
First what you need to do
White.
is find a and b for the first question, then you can only do the second one, okay.
Yes, A and B. Okay.
Next, what we have here is A model with high variance and low bias. So high variance, what it means is that the model overfits. Okay, model becomes too complicated, so it fits the training data perfectly, but is not able to perform well on the test data. Okay, I hope you understand from the videos, lecture videos, theory. Okay, and so that is it actually. So C option is wrong. It does not fit the test data properly. Model becomes less sensitive to the training data. It is too sensitive to training data, so that is wrong as well. It can be simple to understand the pattern of the data. It is wrong. It is complicated model. Okay, it is a complex model. Which the following techniques is used? Actually, got it. Question number 9. All clear.
What's the correct option, sir, for question number 9?
Okay, let me tell you. Question was, I think C. No, no.
The second,
9B. 9B. Yes.
so overfitting.
Yes, it is overfitting. Very nice. Overfitting is the right answer. Option B. Question number 10 is very similar to question number 9. Which techniques are used to prevent overfitting? So regularization simplifies the model. Okay, so answer is C. And a complex model will be overfitting, so that option A is wrong. More epochs, it will get more complicated. Okay, so it will also lead to overfitting, so option B is wrong. So to increase the variance of the model, if the variance increases, also the model will become more complicated, also results in overfitting. So answer is 10C. Any doubt? Since I cannot go into the details of this, okay, because the time constraints are there. Okay, I hope you understand. Okay, for to get to the details, you should take a proper machine learning course, not with deep learning. Okay, then the course will not be rushing through. Okay, you will get the explanation of each and everything properly.
Sir, I have one doubt.
Yes, please.
Sir, how do you find the mean squared error for linear regression problem, sir? I think problem number 8, 8.
Problem number 8, let me see. uh, okay, so
Linear equation, sir, from problem number 7, linear equation is there.
mm-hmm.
From that,
So
find
you have got A and B here. Okay, so what
that is slope and intercept, correct, sir?
very nice, slope and intercept. Yes.
After that, in 8th question, asking MSC,
Yes.
there are totally 10 dependent variable and 10 independent variable is there.
um,
In,
the so try to understand. Okay, for y
okay,
values, y truth, you are given in the question number 7. So say suppose
okay,
minus 0.5267, so you put minus 0.5267 minus the
okay,
value of y prediction, that is given by a plus bx. So a and b you know now. Okay, you put the value of x from this minus 2, so minus 2b plus a is the y prediction. Subtract these
okay,
two. Okay, and
okay, sir.
square this up. Okay, and repeat for every y and x values. Okay, sum those
Okay,
up
okay.
and divide by 7. Okay, got the answer.
Okay. Actually, I work out same way only, sir. But
Very
I
nice.
I not get the I not get that answer for given option. I think.
Maybe the options can be wrong as well, or the calculation is also hard this in this question. You can use the calculator, okay, to get
Okay,
the
sir. Okay, sir.
right answer
Okay.
quickly, correctly.
Thank you. Thank you.
Hmm. Okay, so yes, Shanti. Any doubts?
सर व्हाट ही आस्क्ड अगेन आई गॉट डाउट 7 सैंपल्स आपने कैसे बताया सर क्वेश्चन नंबर 8 का आई थिंक देयर आर सैंपल्स आर 9 to 10 आई थिंक -2 -1 1.2 oh it is 1.2
Acha.
okay
No, no. It is 3 to 3 to 9. 10 is the 10. Yes. Sorry.
yeah and the y is also 10 I guess
Yes. Should be 10. Same only.
okay
I just calculated
thank you
wrong.
sir
Okay.
thank you sir
10 is the right one. I did not see it very carefully. Okay. So let's move on. So what is this? Shanti, you can have it out.
no sir we can move on
Okay. So next we come to this one. So all of these questions are on Bayes theory, so you can understand how much probability is important here. So must understand Bayes theorem properly. Okay. So this questions is not easy one actually. It's a tough question actually overall. Um, so let me explain you properly. Okay. And with just one question you can solve the rest of the questions without me discussing as well. So as you see, so they say that what is this classifier going to classify? So it is going to, first you should understand, it is going to classify whichever probability is more. Okay. So what I need to check is probability of A given x is equals to 1 and probability A B given x is equals to 1. Okay, so they have said that the x will be 1. Okay, so what will you get, A or B? Whichever the value will be higher, this probability answer will be that. Okay, okay, so let's progress. Okay, and so we have to see this one first. Okay, and okay, so you can understand how we formulated the problem. Okay, how you will approach the problem. Okay, so first we need to these two probability, whichever will be higher will be the answer. So if it is higher, first one is higher, the answer will be class A. Second one is higher, the answer will be class B. If both are equal, then the answer will be option C. Okay, so this is the probability we're trying to find. Okay, so we will use Bayes rule here. Okay, so what does Bayes say is PA x equals to 1 is equals to probability. Okay, so what you get is probability of A into probability of x is equals to 1 given A. X is equals to 1 given A, this is written. I hope you understand, it little complicated. Okay, divided by probability that x is equals to 1. So from the problem you can see that you are given probability that x is equals to 1. Probability of A is given 0.6, so that is 0.6. Okay, probability of x is equals to 1 given A, x is equals to 1 given A is given 0.8. Base is, what is going to be the base? Can anybody answer? Base,
It may be 0.8 because it is P probability of x equals to 1. I don't know.
okay, let me see. So if you see carefully, Shanti, what happens is that we have been given x equals to 1 given A has occurred. Okay, that is 0.8. We are not given x equals to 1, P of x equals to 1. So how do you
Uh, yes, sorry. A is B.
So how do you think we are going to proceed? How are you going to calculate the probability of x equals to 1? It is not given in the question directly. Okay, so you have to calculate it today. Okay, so anybody has any answer? What will be the, how we will calculate p of x equals to 1? Somebody must have done the question. Anybody? Anybody who has done it? Sandhya, Santi, and how many are there? Okay, let's see. So Akansha, Bharati, Brunda, Vanam, Deepthi. Anybody has done it? Lalit, Pranjal. I think nobody. Maybe. Okay, let me help the person join. Let me explain after that. Okay, so what you need is p of x equals to 1, which is not given to us, but this is calculated from the principle of total probability. Okay, so what does it say is p of x equals to 1 we need to calculate. We have got two disjoint event a and b. Okay, pa, so it is given by acha, let me see. Okay, little bit wrong.
So please read this p with x
Wait,
or
I am
something. I
reading.
can't. One. Okay.
P x equals to 1 given, oh shit, so this is p of x equal to 1 given a, okay, plus pb x equals to 1 given b. So how do we get the formula? It is something like this. Suppose there are, this is a, and suppose rest is b, this is b, okay, and this whole area is x equals to, suppose this is x equals to 1, okay, x equals to 1. So you can see x equals to 1 probability is sum of intersection of x equals to 1 and a, x equals to 1 and b. Intersection can be written as in the form of conditional probability like this. Okay, so that is how we get the formula here. Little bit of you can revise the probability part actually, because don't think many of you are understanding this one, so try your best. Okay, so just need to put the values now. Okay, uh, okay, so values are a is 0.6 into 0.8, right? So this will be 0.6 into 0.8, then plus pb will be
0.4.
pb 0.4 into, you can see x equals to 1 given b will be 0.3, 1 minus 0.7. okay, so 0.4 into 0.3.
सर ये 0.8 and 0.3 कहाँ से आया मैं थोड़ा समझ नहीं पाई
बताता हूँ.
सर.
So you see here, um, so it is something like this actually. This is the b set, okay, and there you have whole is, this total circle is b, okay, half is x equals to, not say half, some part of it is x equals to 0, okay, another is x equals to 1, okay. So if B has occurred, okay, in this sphere, okay, what I am seeing is either x equals to 0 can occur or x equals to 1 can occur, okay. We have been given the probability of occurrence of x equals to 0 when B can occur, means inside this sphere is 0.7. The other one will be, can only mean 1 minus 0.7. Clear, Shanti?
Got it, sir.
Got it?
Got it.
Okay, so this is how I got the 0.3 part. So this is 0.48. This is 0.12, resulting 0.6. Okay, so we've got 0.6 here, and this is the question here where I was calculating. So 0.6 here. So you got this one, you get 0.8. The answer is 0.8 here. Okay, you need to calculate the other probability as well. Compare those, whichever is the larger one, you get the answer. Okay. Okay, so we are done for today. Hope you enjoyed and learned something.
Thank you, sir.
Thank you very much.
Thank you, sir.
Thank you.
Thank you.
Thank you.
Thank you, sir.
Okay, bye. Now revise these things. Whatever
Thank you, sir.